Hello viewers, welcome to video number 71 of the channel Chemphilic, and video number 71 is the 13th episode of Chemical Thermodynamics, and in the 13th episode of Chemical Thermodynamics we will discuss about enthalpy of the process. So let's start. From first law of thermodynamics, we know that heat absorbed at constant pressure goes to increase the internal energy of the gaseous system plus the pressure volume work done by the gas. When heat is absorbed, work is done by the gas. And this increase in internal energy means increase in the thermal energy, whereby temperature increases, and this is the pressure volume work done by the gaseous system. So heat absorbed is divided into two parts. One part increase internal energy, one part utilized for pressure volume work, and this is equal to change in the enthalpy. So, what we can conclude? We can conclude that change in enthalpy that is delta H, that is equal to heat exchange. That means heat exchanged means heat absorbed or heat released. Okay. So, and we know that H enthalpy is equal to E plus PV. So, it is the total energy content in the system. Here it is gaseous system. One part is increasing temperature, that is thermal energy, that is internal energy, and another part for this work. So, delta H or change in enthalpy is equal to the heat absorbed or heat released at constant pressure. Okay. So, this heat absorbed or heat released or change in enthalpy, what will be the sign? If the heat is released, that means if the process is exothermic, that means heat is released. Heat is released means delta H will be the negative. Okay. Or if heat is absorbed, that means endothermic. If the process is endothermic or heat is absorbed, then change in enthalpy delta H will be positive. Okay. So, heat absorbed or heat released at constant pressure is equal to the change in enthalpy of the gaseous system. Now, enthalpy change during a process is known as the enthalpy of the process. Enthalpy of the process. Say for example, just imagine I am considering the enthalpy of fusion. What is fusion? Fusion means conversion of the solid to liquid. So, this solid is converted to liquid, that is your fusion, and this is liquid. Okay. You know, for any state change, solid to liquid, liquid to gas, or gas to liquid, whatever it is, it occurs at fixed temperature. During the state change, temperature does not change. So, these processes are isothermal. Temperature remains constant during the state change. Okay? And when I'll define the enthalpy of fusion, I have to consider 1 mole of the substance. And obviously, it takes place at the open vessel, open condition. Therefore, it occurs at constant atmospheric pressure. So, during this state change process, pressure remains constant and temperature also remains constant. So, solid is converted to liquid. Here you have to supply the heat. So, if heat is supplied but temperature is not increasing. Temperature is not increasing means when the fusion takes place, temperature does not increase means no change in the internal energy. Internal energy is not changing. What is happening? Whatever heat is supplied, that is utilized for doing the work. What work? Solid is converted to liquid. In the solid forms, the molecules are very close to each other. Strong intermolecular forces are existing between them. But liquid means they will be apart from each other compared to solid. That means molecule has to be taken apart from each other. Therefore, that strong intermolecular force should be broken. To break this strong intermolecular force in the solid so that they become apart, they convert it to liquid state, that energy is utilized. So, energy supplied utilized to break these strong intermolecular forces between the molecules in the solid state so that they can convert it to liquid. So, entire heat supplied is used for this work. No change in the temperature, that means no change in the internal energy. That's why temperature remains constant. So, how can I define this enthalpy of fusion? See, enthalpy of fusion, enthalpy of fusion, enthalpy of fusion, that is denoted by delta HF, is the amount of heat required, amount of heat required for the conversion of 1 mole of the substance, 1 mole of the substance from solid state to liquid at constant pressure and without change in temperature. So here you have to remember, we consider for 1 mole of the substance and constant temperature. As I told you, though you are supplying heat, but that heat is used for doing the work, breaking the strong intermolecular force. It is not increasing the thermal energy or temperature. So constant temperature, and it occurs in the open condition, open vessel. So occurs under constant atmospheric pressure. So this is the definition of enthalpy of fusion. Or you can write it as enthalpy of fusion is the change in enthalpy when 1 mole of the solid is converted to liquid at constant pressure and constant temperature. Okay. Now coming to say enthalpy of vaporization. This is enthalpy of fusion. Now what I am telling, enthalpy of vaporization. Vaporization means this liquid is converted to vapor, and this is known as the enthalpy of vaporization, that is delta H vaporization. Okay. How can I define that? In the similar way we can define. What will be the definition? Definition will be enthalpy of vaporization is the amount of heat required for the conversion of 1 mole of liquid to the vapor state at constant temperature and pressure. Or you can write it as enthalpy of vaporization delta H vaporization is the change in enthalpy during the conversion of 1 mole of liquid to vapor state. That is the enthalpy of vaporization. Similar way, enthalpy of sublimation. Enthalpy of sublimation. What will be the definition for the enthalpy of sublimation? See, we know that solid first converted to liquid and then liquid converted to vapor. This is the state change. But if directly the solid is converted to vapor, that is the sublimation. So, what will be the definition of enthalpy of sublimation? So, enthalpy of sublimation is nothing but the enthalpy change or change in enthalpy when 1 mole of solid converted to gas. What is the condition? At constant temperature and pressure. So during state change, even in the vaporization process also, say water. Water is vaporized or boiled at 100 degrees centigrade and the temperature remains constant till all the water is boiled off. What is the reason? Because the energy supplied, you are supplying energy, that heat supplied is not increasing the thermal energy, not increasing the temperature. It is completely utilized for the work. What work? To break the strong intermolecular force. Intermolecular forces between liquid molecules are much greater than gas. Gas means molecules will be far apart. So, it has to break the intermolecular forces so that molecules will go far apart. Similarly, enthalpy of sublimation means change in enthalpy when 1 mole of the gas, change in enthalpy when 1 mole of the solid is converted to gas at constant temperature and pressure. This is the enthalpy of sublimation. Similarly, we can write it as enthalpy of condensation. What is that? Enthalpy of condensation means the condensation of this vapor to liquid state. So, as it is the energy or heat released during the conversion of 1 mole of the vapor to liquid state at constant temperature and pressure. Or you can write that this enthalpy of condensation, this is nothing but the change in enthalpy when 1 mole of gas 1 mole of gas is condensed to liquid at constant temperature and pressure. This is enthalpy of condensation. Now, then next one, enthalpy of ionization. Similar way, enthalpy of ionization. Okay. So, say you want to ionize the metal. That means electron is removed from the metal. But ionization will be occurring at the gaseous state. So, if you take the metal, solid metal, this is solid. First, it has to be converted to liquid metal. You have to supply energy. Then it will go to the gaseous metal. Then it is converted to ions. That means metal ion plus release of electron. Then how can I define this enthalpy of ionization? Enthalpy of ionization means the amount or the change in the enthalpy when 1 mole of the gaseous substance, say gaseous metal, is converted to ion at constant temperature and pressure. So, this is enthalpy of ionization. Now, next one which is important, that is enthalpy change or heat of the reaction. This is called as heat of the reaction. Heat of the reaction, or this is also known as enthalpy change. Enthalpy change of the reaction. Say your reaction is A is converted to the product P. A is the reactant and the P is the product. Okay. If enthalpy, or you can take it as R. R is the reactant, P is the product. Okay. Say enthalpy of the reactant, see I denote it as HR. This is enthalpy of reactant. Similarly, HP, this will be the enthalpy of product. Now, enthalpy of the reaction, delta H reaction, that will be is equal to the difference between the enthalpy of the product and enthalpy of the reactant. So, difference between enthalpy of product and reactant. Okay, that is the heat of the reaction or enthalpy change of the reaction. Okay, so this is all about the enthalpy of the processes. That means enthalpy change during any process which occurs at constant temperature and pressure. I am telling about the physical state change, and that is known as the enthalpy of the process. Hope you have understood. Thank you.